Unit 1, transformations on the coordinate plane. We're going to talk about rotations now. Remember, when we're talking about rotations, we're talking about clockwise and counterclockwise. And anytime you get directionally challenged like I do, always think about a clock face, and clockwise means the direction that the clock generally ticks in, and counterclockwise would be that opposite direction. All right, so when I'm talking 90 degrees, I am talking about a quarter of a circle. It sort of makes that L shape, right? Or a corner. Uh-oh, lights just went out again. Shoot. When I'm talking about 180 degrees, that is a half a circle. It's a flat straight line. The rotation is the same whether we go clockwise or counterclockwise. On the clock itself, 180 would be between 12 and 6. So whether I go clockwise or counterclockwise, I would end up in the same location, either direction. And 270 would be 390 degrees turns. So 390 degrees turns is the same as if I had just gone 90 the other direction. Three 90 degrees turns, or 190 in the opposite direction. So I can go 90 clockwise is the same as 1, 2, 3 counterclockwise. Likewise, 90 counterclockwise is the same as having gone 1, 2, 3 clockwise. So we can use our knowledge of 90 and 180 and know that 270 is just going to go in the reverse direction. 1/4 turn. For 8th grade purposes, we only rotate around the center of our graph at the origin. All right, so identify a rotation that can take the figure that starts off in quadrant 2 and moves to quadrant 1. So it starts off here. This is our pre-image. And this is our after image. What rotation would take us from quadrant 2 to quadrant 1? Well, we have 2 different ways to describe that. I see that it's not gone 2 times around. It's only gone 1 time around. This is a 90-degree turn clockwise. And 90 clockwise would be the same as going 270 counterclockwise. Counterclockwise. That is a long word. We can use our patty paper to test out rotations as well. Patty paper is not just for reflections. So if we weren't sure about what style of rotation that was, we could draw it in our pre-image and make sure to draw in your origin so you know what you're turning around. So if I'm looking, it takes, I'm spinning around the origin, 1/4 turn to get there, right? It takes 1/4 turn, or a 90-degree turn. If I did 180, that would be 2 90 turns. So this is 90. This would be another 90. It would make that straight line. All right. Let's keep looking at examples with rotations. Here we have this figure again, WXYZ trapezoid. This time we're going to rotate the figure 180 degrees clockwise. Does it matter whether we go clockwise or counterclockwise? Not really. And we're going to identify the new coordinates. So just like before, we're going to start by drawing our origin. We're going to draw in our vertices. I don't usually bother with the whole shape because I just need to know where those dots are so that when I draw the new shape, I know where to place those dots. And then I can draw the lines in later. All right, I'm going 180, which means I'm doing a half circle spin. So I'm going to do 290 turns or a half circle. So this would be a 90 clockwise, would look like that. But I want to go 180. So we're going to go kind of all the way upside down. And now my new coordinates are located here. This time around, it's not a mirror image. It's all the way upside down. And I'm going to read my new coordinates here. So I've got W is now at 2, 2. Or it used to be at -2, -2. Now it's at +2, +2. Y or X used to be at -2, +1. Now it's at +2, -1. They're kind of the exact opposites. So now it's at +2, -1. Y used to be at 2, 1. Now it's at -2, -1. And Z is out there at -4, +2. So now that I know where these are supposed to go, I'm going to graph it. Here's X prime. Here's W prime. Y prime. Oh, my lead broke. And Z prime was over there at 4, 2. Okay, so when I draw this in, you should notice this looks different than when we did the reflection over the x-axis. It is now facing the opposite direction because it did a spin instead of a flip. So what trick can I use to help me rotate the figure? One trick we can use is use that patty paper. And when we use the patty paper, I always like to do step 1 as draw the origin, sort of a crosshairs. And then step 2, draw the corners, the vertices. And then step 3, spin it however you need to spin it and identify your new coordinates, your new points. Okay, there's another trick we could use, and I will show you on the one down here where it says try it. It says rotate figure ABCD, that's this rectangle here, 270 degrees clockwise. What are the new coordinates? So we can use our patty paper and we can do that. But I want to show you another way, if I don't have patty paper, that I can figure out where these coordinates belong. So if I'm doing 270 clockwise, that's 3/4 turns. 1, 2, 3. And now I'm going to look at my paper as if my number lines are correct. So pretend for a minute that these are +1, +2, +3, +4, and these are -1, -2, -3, -4, and that these are the negatives and these are the positives. So if I read this as if my number lines are correct, my rectangle ends up in quadrant 2. And A is now at -4, +2. So from the origin, I had to go left 4, up 2. So -4, +2. A little hard to write sideways. Did you know that? B is at -4, +4. -4, +4. C is at -1, +4. And D is at -1, +2. Okay, I'm going to turn my paper back to the right direction and maybe clean up my numbers so they look like numbers instead of Z's. And then I'm going to show you what that rotation looks like with the patty paper. So I like to use up my patty paper as long as it takes until I kind of don't have any more patty paper left. So I don't have to keep getting new ones. So step 1, I draw my crosshairs. Step 2, I draw in my vertices. Does it have to be perfect? No, just needs to get it right on the grid lines in the right spot. Okay, so 270 clockwise is 3 spins this way or 1 spin the other way. So I'm going to do 1 spin in the opposite direction and see, just double check that I did get my numbers in the right spot. So I said A should be at -4, +2. So -4, +2, there's A. B should be at -4, +4, there it is. I said C should be at -1, +4, there it is. And I said D should be at -1, +2. So the trick of spinning my paper got me the same coordinates as using the patty paper to spin them. Now I can graph them and show where my new points belong. And there's A, B, C, and D. So is this the only rotation we could have used? Is 270 the only rotation that gets us to that location? No. We could also have done 90 degrees counterclockwise to get to that same spot. It gets to the same spot as 270 clockwise. Rotations, patty paper is option 1, or spinning your paper and reading your new coordinates as option 2. Real quickly putting it together, I wanted to show you what this might look like with multiple steps. So I'm going to look at example 2 here, where it says the vertices of a rectangle are A, B, C, D. We're going to graph those in just a second. Then we're going to rotate our figure 90 degrees counterclockwise, and then reflect it and find our new coordinates. So first I need to graph my pre-image. So A at -3, -3. There's A. 1, -3. There's B. 1, -5. There's C. And -3, -5. There's D. So my pre-image right here. And we're going to do 2 things. First, we're going to rotate it 90 degrees counterclockwise, and then we're going to reflect it in the y-axis. So start by getting my patty paper. I've got a little bit of space left right here in the middle of my paper, so I'm going to use that. So because I'm going to rotate first, I'm going to start by just drawing my crosshairs at my origin and pull out my 4 vertices, label them so I know which one's which when I spin it. And it says spin 90 counterclockwise. That means not the way the clock is turning, but the other way. So 90 clockwise or counterclockwise, excuse me, would end up over here. That's step 1, but then it says reflect it in the y-axis. So now that we've spun it, now we're going to reflect it across y. So we're going to flip it over. All right, we've flipped it over. We now have our new coordinates. We know where to read them at. So A is at the same location it used to be. A prime is at -3, -3. B is up here now at -3, +1. C is at -5, +1. And D is at -5, -3. And then we can plot those points. -3, +1. B prime, C prime, and D prime. So after a rotation, got it from here to here. Then we flipped it over and it got in its new location. These two figures are congruent because they are the same size and the same shape. Their side lengths didn't change size after all these movements. Rotations.